Welcome back. These are the remaining two aromatic electrophilic reactions that I want to discuss with you. We've already looked at alkylation, acylation, and chlorination or halogenation in general. Okay. Now we got sulfonation and nitration, and this would complete adding an electrophilic substituent onto a benzene ring. Once we know how to add a substituent to a ring, then we look at the effect of substituents on that ring. Okay, so let's go ahead and complete the two of the remaining reactions. The first of them is sulfonation. Okay, so sulfonation is when sulfur trioxide reacts with sulfuric acid. So this is how you probably would see your reaction written to you on the exam or on a quiz or on a homework or on a practice worksheet or anywhere. Okay, so the sulfur trioxide reacts with sulfuric acid, okay, and it produces, now this is what you really have to remember, okay. I'm not sure I'm going to give you that information, so this would be SO3H. This is your electrophile, plus you also produce a base, which would be HSO4 minus. Okay. Now, what I'm going to box the electrophile in maybe a different color. So this is your electrophile. Okay. Now that's what was going to react with your benzene ring. Okay. So let's get a different color. So here is your benzene ring. Okay. Plus your electrophile, SO3H, right? Now keep in mind, the benzene ring already has two hydrogens to start with on either side of this double bond, right? Now what happens? Let's get a different color, perhaps the red again. Okay, so the double bond attacks the sulfur containing the positive charge, establishing that link. So here's your hydrogen, and this is the bond connecting SO3, and then there's another hydrogen here, but then the double bond results in a positive charge here on this carbon, right? Now what happens? Now you can draw the resonance structures like I've shown you for this. This is your intermediate, so you can draw resonance structures for this. Now let's go actually complete the product. So let's get a different color. This would work. So the base now comes and grabs this hydrogen, okay? Which means this bond would come over here, okay? So the product would be that's basically your product. It's no different than anything else we've done so far, okay? It's just you have to remember the electrophile, okay? Once I give you these reactants, you need to know what your electrophile is. The base, you can always write it as B minus, okay? Even if you don't remember the actual base, you can write it as B minus, which I'm perfectly happy with, but I do want you to write the electrophile correctly the same way I've been doing it. All right, the last of the reaction is nitration of benzene. Okay, and this is clearly indicated by concentrated nitric acid and sulfuric acid. Okay, so when nitric acid and sulfuric acid HNO3, it's nitric acid, plus H2SO4 is sulfuric acid, and they react. They make nitronium ion, which is NO2 plus I'm going to call the base as, I think you can have H2O is one of the base. Okay. Okay, so this is your electrophile. So I'm going to box what the electrophile is, like I did on the previous occasion. You do have to remember the electrophile. I probably won't tell you what the electrophile is. So I will only give you the reactants. You would have to figure out the electrophile. So if I give you this as reactants, then this would be the electrophile. Now let's go get our product written. So let's go get our blue. So you got your benzene ring. This reacts with your nucleophile. Keep in mind, your benzene already has 2 hydrogens here. So let's get our colors. Orange might work, actually. I haven't used orange much. So this double bond now connects the nitrogen to this carbon, right? So let's get our red color back. Okay. So the hydrogen stays there. This bond makes the connection between this carbon and the NO2. This hydrogen stays where it is. You have the positive charge here. Now the base, which is water, comes and grabs this hydrogen, and in the process, this bond comes back in, and then any bond coming in is equal to a negative charge. That means our product would be, you do not have to really show the hydrogens. At least the top one you can show. The bottom one is up to you if you want to show it or not. The top one, yeah, you can show it so you know what is happening. So there you go. This is your product. Okay. So this is the product for the sulfonation, and that's the product for the nitration. Okay. So what we have essentially done here is we've added a substituent. The substituent is essentially the electrophile. So we started with, say in this case, we started with the plain benzene ring, right? And we ended up with the SO3H. Now the SO3H is your substituent. We started with the plain benzene ring, and now we added a NO2. Your NO2 is the new substituent on the ring. Now, if you were to add another substituent to this existing ring containing the NO2, then the NO2 has a say. Okay, it just doesn't allow an incoming substituent to certain positions on the ring. It only directs it to a certain other position on the ring. Okay, that's what we meant by substituent directors, that is ortho, meta, para. Okay, which we will discuss separately in a separate video. All right. So this is all I wanted to show you as far as just the reactions themselves go. Now in the successive videos, we are going to look at the effect of substituents on an incoming additional substituent. All right. So stay tuned.